Hello everyone, welcome to our fourth webinar in our GIS for Housing series, Modernising Social Housing through Location Analytics. So I am Isabel Clouting and I'm a Customer Success Manager at Esri UK, leading on our social housing sector. And I'm joined today by Lindsay, the GIS Specialist at Believe Housing, Jamie, GIS Analyst at Sovereign Network Group, and Adriana, our GIS Consultant at Esri UK, who looks after our technical demos in the social housing space. So just a few bits before we get going. The webinar is being recorded and a link will be shared in the follow-up email after the webinar. It'll also mention any links that all the speakers mentioned throughout their presentations. And there's not going to be a live Q&A, but we will have a Slido open for any questions. And so you can access the Slido either by scanning the QR code, or you can go directly to slido.com and enter the event code housing2703. To access the Slido. And you can input any of your questions you want there. I'll give you a second just to scan that code, but we'll bring it back up at the end as well, in case you have any questions towards the end. And so now onto the webinar, Modernising Social Housing through Location Analytics. So it's clear there are a lot of challenges in the social housing space, being tasked with providing homes to those most in need, managing a massive number of properties, ensuring a supply of new homes for a growing population, and providing services for those in social housing is a very large task with lots of moving parts. Throughout the regulations and recommendations to the industry, there is a trend of needing good quality data, letting organisations understand what they have, the state of the properties they manage, the tenants in these properties, and identifying and moving to resolution of any issues that they face. But what uses good data if it's not used, analysed, and accessible to those who could use it to gain insight? At Esri, we believe in the power of geography and geospatial analysis to bring together data and make it more accessible, adding a new perspective to the data an organisation holds and collects. Housing at its very core is a spatial sector. Each home has an address, and behind each of these addresses is a complex network of data that could tell you a lot about it. The location and type of property, its history of occupancy, demographics of the area, proximity to amenities and green spaces, the utility networks that make a home function, and the transport links that connect a community, all beginning from a point on the map. And core to Esri's offering is the data that sits behind the system. Esri UK has some great partners in the data space, providing detailed and authoritative geographical data to those, and these include the Ordnance Survey, providing their authoritative and detailed master map and address-based data, Blue Sky and their detailed imagery and derived products such as the National Tree Map and digital surface models, and LandCloud, which is a vast data store of useful data including environmental constraints, planning information, and property information such as valuation data. The Instant Atlas products give customers the ability to explore and interrogate over 15,000 indicators to help you better understand your localities. And included within the ArcGIS system is our Living Atlas of the World, where we curate a range of authoritative open data from organisations such as Natural England and the Office for National Statistics. Location links to all of this data, and a GIS can analyse and visualise these connections, bringing powerful insights into all parts of a social housing business, unlocking organisation-wide spatial insights. So as I mentioned at the start, today we're joined by two customers to share how GIS is used in their organisations and the value they're seeing from using location as that tie for their data. First up is Lindsay from Believe Housing to share with us how Believe started their GIS journey just 2 years ago and the value they are already seeing. So over to you, Lindsay.
Thank you, Isabel. I'll just give me a second to share my screen.
Yeah, I can see it.
Yeah, great, right. So good morning, everyone. Today I'm going to be talking about our 2-year epic GIS journey, and I'll be sharing the approach we took to solving some of the problems we encountered along the way, as we really did start from GIS ground zero. So just to start off with, a little bit about me. I joined Believe Housing just over 2 years ago now as a GIS specialist. I was initially tasked with procuring the software and then deploying and managing it. And I also look after all the geospatial data. But before joining Believe, I previously worked in the GIS sector in utilities, renewables, and local government. So a little bit about Believe Housing. Believe Housing, we're one of the North East's largest housing associations. We manage over 18,500 homes and we cover an area of more than 860 square miles. And our properties range from our urban coastal neighbourhoods over here in the east to our more rural neighbourhoods over in the west. We also have more than 600 people working at Believe and delivering services to our customers. So before we got going with everything, we had a clear vision of what we wanted, which really did help. We knew we wanted to unlock our assets with our assets and customer data. We wanted to be able to visualize that data and make it available across the whole of Believe Housing, and then be able to analyze that data to produce actionable insights. We used images like this one you can see here on the screen to share this vision with our colleagues, many of whom hadn't previously used GIS. And this really did help get buy-in from the start and hopefully helped reduce any hesitancy that people might have had to new technology when it was rolled out. So now we are embarking on our journey. And first of all, I needed to understand what our problems were. And first of all, I needed to get an understanding of how data was stored and where it was stored. And it soon became apparent that we had data stored in a variety of places and a variety of different formats, including things like spreadsheets, databases, and also a data warehouse. But luckily, the data warehouse was actually going to be good news because it meant that we that Believe was going to store this data, use this data warehouse as a central repository. So I knew it would become handy in the future to be able to source all my internal data from. It was also proving time consuming for colleagues to find, access and link different data sets together, particularly internal and external data. And this ultimately meant that patterns and insights could have been missed. So the solution was to deploy GIS as an organisation-wide application that would provide a single storage location for geospatial data and have multi-user access. By having the ability to combine and analyse both internal and external data and make it visually accessible to colleagues, we knew that it would help drive an evidence-based approach to decision making, which in turn would facilitate a targeted-based approach. So basically, if we can see what's happening and where it's happening, we can put in place the appropriate actions and solutions. So all this helped to inform our year one roadmap. So back in January of about 2022, I suppose first of all, I need to hold my hands up and say that our journey wasn't quite as linear as what this image might show, but it'll hopefully give an idea of how we progressed. So in January of 2022, I started information gathering and liaising with all of our business directorates to get an idea of what people wanted. So then we went out to tender. We had clearly defined requirements. Lot 1 included a list of all of our GIS software functionality, and Lot 2 included all of the mapping and geospatial data that we needed. So this included things like OS address space, OS master map topography. We had Blue Sky's national tree map that we were interested in, and I think also other land registries, land ownership boundaries. So the tender was awarded to Esri in around May of 2022, and it was also for the supply of the software and supply of data as well. And we start the software installation around about September. And it really was a collaborative approach between Esri and Believe Housing IT infrastructure engineers. We went for a full suite of projects, which included ArcGIS Pro, ArcGIS Enterprise, and ArcGIS Online. So then towards the back end of 2022, we were now in the setup stage. And this really involved building the foundations of our GIS system. So we loaded data into the Enterprise Geodatabase. We set up models to automatically schedule daily data updates, which means that information shown across all of our GIS applications is as up to date and as current as what's shown in our source database. And I also created a standardized base map, which would rolled out across all of our different applications. So now we're at the midway stage of our journey, which is the point of no return. We discovered that we had a new set of challenges to overcome. Our first new problem is that we now had all of our internal data and external data and mapping ready to use, but what was going to be the best way to deploy it to our colleagues in a user-friendly way? Well, the solution was to create an organ-wise interactive web map app that we've now called our Asset Atlas. And we also wanted to create bespoke directorate and team and project level web maps as well, which would have restricted user access. But this in turn created a new set of problems. How do we keep all of the GIS maps and apps together in a single location? Well, the solution was to create a GIS hub using the Sites app website builder, which is available in ArcGIS Enterprise. So with all this in mind, we're now in year 2 of our roadmap, and we're at the start of 2023 in the deployment stage. So we started publishing web services that would then feed into all of our different web apps. I then started building the bones of our GIS hub, which was going to be our one-stop shop for all things GIS related. Then created our asset atlas, which, as I've just mentioned, is our organisation-wide web map, and then moved into the more bespoke web maps, which would have limited user access to safeguard any sensitive data which might be included in those. And now we're at our exploration stage, which basically we're looking to see how we can provide GIS as a solution to the wider business. And we've just recently started mapping things like damp and mold repairs, so we could see if there was any particular locations where these repairs were happening to see if we could target those. We also mapped incidences of no access, so if we have operatives going out in the field, they could check the web map to see if any of our customers had a high level or a high incidence of not allowing access to the properties, so it would help them plan the day. And we've also got lots more going on as well. So where are we now with all that in mind? Well, we use a selection of GIS apps such as web mapping, dashboards, and Survey 123 to interactively deliver data to our colleagues. We use web mapping to empower colleagues to find the information they need to respond to questions and queries in a timely manner. We use Survey 123 to improve our responses to customer satisfaction, and lots more. So I'll be talking a little bit more about this in the next slide. And also I'm going to give a demo towards the end of the presentation of how colleagues are using the apps on a day-to-day basis. So, before I move on to the demo, I just wanted to share some of the innovative ways we're using GIS, I believe, with just a few core data sets, really. For example, using the EA flood map for planning data, which is an open data set, we worked with our risk and assurance team to identify that out of our 18,500 homes, 309 of them fell within a flood zone. This meant we were able to hand over much more accurate information to our insurers about properties that could potentially be at risk. Also, and I do think more importantly, we combined this with our customer information to highlight if we have any customers who might be particularly vulnerable in these properties. So in the event of a flood, we would know who to provide help and support to first. Then on a separate project, we worked with our health and safety team, this time using OS important buildings and sites layers, which again, it's an open data set. We combined this with Blue Sky's National Tree Map and the Land Registry's land ownership boundaries to locate where we have trees in our land that are in close proximity to locations with high footfall, such as schools and hospitals. So we know where to target first for tree surveys. And then just recently, we've also started working with the environment team to assist with their environment strategy and biodiversity plan to work out how much green space we have on our land and to find out where it is. To do this, again, we used a combination of our core data sets, including OS master map topography, the land ownership boundaries, and the national tree map. And from this, we were quickly able to determine that we have over 8,000 trees and approximately 400 hectares of green space, which also includes gardens within our land ownership, all of which have a lot of untapped potential. And to analyse this data further, we then used hotspot analysis to show where there are concentrations of green spaces to enable us to identify where we could create green corridors out of our within our more urban neighbourhoods. In the example here on the screen, in Peterlee, we can see that our green spaces form a natural corridor to the north and to the south of the town. And also when we pull in information from places like Natural England, including national nature reserves and ancient woodland, we can see this area actually really lends really well to improving biodiversity. And finally, our major works team are using a survey set up in Survey 123 to capture customer satisfaction responses for work that is being carried out on their home. As soon as the work is finished, the contractor hands the customer a postcard containing a QR code to the survey. If the customer responds negatively, an email notification is sent to the relevant people at Believe, so the complaint can be dealt with swiftly. Previously, before the system was put in place, every quarter or so, a member of our customer service team would select about 15 customers to call and would carry out the survey manually. This was obviously time consuming and gave us limited data on contractor performance. So over the course of a year, this would give us about 60 responses in total, and it could take weeks to even pick up if there had been an issue, let alone rectify it. In comparison, we are now reaching every customer that has had work done. And so far, since we started the survey back in, I think it was about September of last year, we've had responses from 1,124 customers, and it doesn't stop there. Our aim is now to respond to a customer complaint within 2 hours, and if possible, to get the contractor back to the property to rectify the issue the same day or the following day, as it's much more easier to do if the contractor is still on site. And honestly, it must be having a positive impact on contractor performance. Also, we are getting very few negative comments from customers, to the point where our major works team sometimes query if the email notifications are working, and I reassure them that they very much are. So these are all quantifiable and actionable insights, mainly driven by location, that are helping improve services across Believe. And I'm now just going to give a very quick overview of our GIS hub and show how the Asset Atlas is being used as an organisation-wide solution. So I'm just going to jump off the presentation shortly and go into the demo. So we have a link to the GIS hub on our Believe Housing homepage, so all users across Believe can find the link quickly and easily. All they have to do is scroll down to our quick link section and they can find the GIS hub here. So when a user clicks on the GIS hub, their credentials are inbuilt, so they don't have to remember another username and password. So the GIS hub opens up. And the first thing I really wanted to mention is that it was important for us to be able to customize the app so that it would be recognizable to our users who so they could recognize it as being one of our own applications. And the Sites app gave us the flexibility to do that, so we could style it using our own graphics. So the GIS hub opens up with on the home page, and we just get a little bit of information about what it is and a little bit of information about GIS. Like I said at the start, a lot of our users hadn't used GIS before. And we've also got the ability to build in additional pages. So we have a map gallery page, an asset insight page, and a help page. The help page just contains links to videos, so that people, if we have new starters, they can come here and watch these videos in their own time to get an overview of how to use things like the Asset Atlas. Then in our Asset Insights page, we have an Asset Essentials GIS dashboard, which I'll just give that a few seconds to load. It's fully interactive and it includes graphs showing all of the main important points about our assets. It also includes a counter, so we can see there that we have 18,500 current assets. And it also includes a web map here. So users can go on here, anybody across the organisation, and answer simple questions about our assets, such as they want to know how many one-bedroom bungalows do we have in Peterlee. They can go to the number of bedrooms graph, click on the one-bedroom bar, then navigate to the archetype graph and click on the bungalow bar, and then navigate to the location graph and click on the Peterlee location. Very quickly, they've been able to answer that question that we have 298 one-bedroom bungalows in Peterlee, and also the map changes just to show you where the location of those bungalows are. So very simple and easy for everyone to use. Then if we move on to our map gallery, this is the page where we hold all the links to all of our web maps. So if I scroll down, we can just see at the start we have our organisation web maps, which includes our Asset Atlas that I'm going to do a quick demo of in a moment. But then as we move down further, we've got our directorate level web maps, which show links to our team web maps. And these have restricted user access. So only people within those teams can see the information. And then if we dive in even deeper, we have restricted project and special interest group web maps as well. But like I say, for the purpose of this, I'm going to demonstrate how we could use the Asset Atlas. So a user would come in and click on the link. To save time, I already have it open here. And the web map opens showing the map frame, front and central. It includes Durham County boundary, and it's currently showing our current assets color-coded by region. So we have our East region, Central region and West region shown there. To the left is our contents panel, which contains all of our different data sets like our assets, development and land ownership. And if the user clicks on the little drop down arrow, they can see all the different data sets that we've got as well. So for the purpose of this demo, I'm going to show how a neighbourhood officer who is sat in our office over here in our theme location, how they can use it to respond to a query from a customer who lives right over in the west of our region in St John's Chapel, which is right over here. The customer has rang to say that there's a problem with the footpath to the front of the property and that there's a large tree in the front garden that's also causing an issue. So if the officer wanted to visit the property and drive all the way from our office over here, right the way to St John's Chapel, this is about a 2.5 hour round trip, but instead they can find the info they want right here on the web map. And to do that, the officer could initially type in the address, but I know where it is, and just to save time, I'm going to zoom right into the location. And our property that we're interested in is number 11 Longdale Grove, which we can see here. So before the neighbourhood officer starts to answer the customer query, they might want to find out a little bit more information about the asset as well. So they can simply turn off that layer, go down to archetype, and we can quickly see that the property is a house, which we can see over here in the legend. We can also see the construction year band, which is between 1945 and 1964. If the officer wants to find out a little bit more information, they can click on that and a pop-up will appear, and we can easily see that it was built in 1948. And to add to that, we can also look at the construction type and see that it's a traditional build. It is of 3 bedrooms and it's also currently managed by us. But then the neighbourhood officer might also want to find out a little bit of information about the customer. So we can click on our customer profile information and click on the age band. And there very quickly we can see that the customer who lives at this property is aged between 60 and 79 years of age. So just very quickly we've seen there how we can find out lots of additional information. But to start answering the query, I'm going to just turn back on our current assets by region layer. To look at the problem that there was an issue with the footpath to the front of the property here, we would then want to go to our land ownership information and turn on our first layer, which includes our land ownership information, which is owned by us, Believe Housing. So we can first of all see that, yeah, that footpath does fall within our land ownership. But to get a clearer view of ownership, we can also turn on Durham County Council's adopted highways information. This again is an open data set, so it's available for anyone to view. So the neighbourhood officer can now see that that problem with the footpath is actually a problem belonging to DCC, so they would know to pass that information to the relevant team at Durham. Then looking at the second issue, which was a problem with a tree in the front garden, the neighbourhood officer could then navigate to our tree information and turn on the tree locations. And this shows the location of all trees which are above 3 metres in height. If the neighbourhood officer clicks on the tree, just expand that, we can see that the average height of that tree is just below 4 metres. So they can tell instantly that, yes, it is a sizable tree. But we want to get a better picture of what could be going on at the location. So the neighbourhood officer can also turn on the tree crowns. And we can see that, yes, it is covering quite a large section of the garden, which may be inhibiting access to the front of the property. And it also appears to be overhanging here, overhanging the property, which could be causing problems with guttering and clogging up guttering and things like that. So the neighbourhood officer now knows to hand that to our estates team. So very quickly, we've seen that with a few clicks of a button and within less than 5 minutes, the neighbourhood officer has been able to respond to this query quickly and efficiently. So just now to finish, I'm going to jump back on to my presentation and give a final summary. We've taken an organisation-wide approach to our delivery of GIS, which encourages cross-directorate collaboration. All users across Believe Housing can access and view a single truth of the data. This has enabled us to create a digital profile of our assets, our customers and our neighbourhoods, all viewable from a desk-based environment. This has led to time savings for our users, faster response times to our customer queries and complaints, and produced targeted responses to issues driven by data and not guess estimates, which has all resulted in a better outcome for our customers. So finally, I think to answer our first initial question of have we reached our vision? Have we recognised our vision? And I think that we have, yes, but as it says on the screen here, the journey still very much continues. So thank you for your time, everyone.
Thank you very much, Lindsay. It's great to hear how far you've managed to get in just 2 years and see all the results that you're already getting for Believe. And so I'm now going to pass to Jamie, who works at Sovereign Network Group as their Senior GIS Analyst. Jamie's going to talk through the constantly evolving GIS system at SNG and how this has evolved alongside his own career path in the business. So over to you, Jamie.
Yes, hello there. I'm Jamie here at Sovereign Network Group. I'm going to just go through my GIS journey from beginning to where I am now and how I have kind of progressed with GIS within SNG. So a little bit about myself. I've been here at SNG for nearly 10 years and almost 4 of those have been solely focused around GIS. When I started my ground journey, it was within the grounds maintenance team in the contracts side of the business. And what they were looking to understand was how can we identify grounds maintenance sites using GIS and move away from the traditional paper colouring pencils style of plans. So what we did is we kind of started using what was ArcMap. And here we can kind of see what it used to look like on our design. We wanted to see where our contractors would be looking to kind of maintain the areas that we have as part of a grounds maintenance contract. You know, there'd be different types of these contracts. There might be ones that might want to look at how much measurement that site has per like a square meter, for example. So what we would do is we would use the GIS to kind of digitize these areas and be able to provide a total area in meterage for a contractor to kind of base the costs and the type of work that they'd be doing here inside of, you know, the grounds maintenance site itself. So using that, we would be able to then implement that into kind of like a pricing framework that would, you know, form the basis of our grounds maintenance contract. It would have all of the information, all of the contractor information, and the contractors we were able to kind of share these maps with so that they could see the areas that they were looking at on the site, on the ground, in a clear and concise way, rather than, you know, having someone scribble down on a piece of paper, oh, this is an area that you might need to maintain. So then following on from this, this was very much kind of like basic level entry for myself. I wanted to kind of push myself, and I started looking into the realm of, you know, the inbuilt tools such as Model Builder, and trying to understand if there was a way that we could kind of look to automatize processes within the sort of contract. You know, is there a way that if we're doing repetitive steps, can this be automatized for us so that it takes away the need for us to be doing a lot of manual intervention? So using that model builder, I was looking to kind of see, right, if we need to provide an update to this inherently large data set, how can we look at taking the steps we would do manually to kind of present it in an automatic way that we would just be able to simply open up the model, click on a button and let that run. And that's what it used to kind of look like in the old ArcMap style. But there would come a point within that model is that there would still be the need for that manual intervention. There are certain tools that weren't available at the time, so it would be that we would use the model to get to a certain point, finish up the rest of the update and carry on from there with that manual intervention. But picking up on that, it was allowing me to understand how GIS kind of worked, all of the type of different tools that you would essentially use day to day, finding them, what they kind of did, and how that would help us, you know, move forward with our grounds maintenance contract. It was then kind of moving on. At that time, I'm still not technically part of a GIS team. I'm still sitting inside that contracts management team, but I'm still wanting to try and find things within my skills as, you know, the GIS side of things. What more can I do to improve my skill set to kind of build my skills and reach a higher rank within, you know, the sort of business, that kind of thing. So what I was doing is looking at the My Esri portal to understand Python skills and all of the various training materials that are available in the My Esri portal. Really did then kind of help me to kind of develop what that would look like inside our portal environment. And a portal environment is essentially what the enterprise kind of sits in. You've got that and all of our custom sort of layers, our web applications, and we started branching into the hyperlinks to understand that if we wanted to have a grounds maintenance plan that had been provided in, say, like a PDF format, how could we make that more accessible to the business and also to people that might want to click on that? So we started exploring hyperlinks and developing that within the portal so that if you wanted to bring up the pre-produced plan for that site, you could simply click on the hyperlink and that would then give you all of the information you needed at your fingertips for that particular site, whether that was the total square meterage, what type of ground maintenance types there were, and on all of this information that we could kind of break down. And if there was ever a call around that particular site, we would have that information readily available for our people, staff, and customers, residents, all of that sort of thing would be available to them simply by clicking that button. So not only that, I started to kind of develop into more data sets, which came with more skills and more understanding of how data is kind of intertwined into the GIS and our internal other data systems. So we were starting to look at trees and how can we ensure that our tree data is kept up to date, and where that kind of plays into using externally available data. We have ours with a contractor who tends to kind of do the surveys for us, and we're able to produce that data internally, but also liaise with them externally through the use of GIS. Initially, this was around like the Collector app, which is now ArcGIS Field Maps, and that sort of thing is allowing us to collaborate with our contractors, but also our internal staff, that we can now visually represent our trees on a map across our entire stock. Around the sort of 2020 period, when we were kind of into COVID times, and we were able to kind of visualize COVID results as dashboards and interactive web maps in our sort of business to understand where our risk was. We might have had schemes where we've got elderly residents that are at higher risk, and we wanted to understand those. I was able to then start kind of flow into the GIS team and start my progression as a GIS analyst. And what that meant for me was that I was then starting to become responsible for pretty much all of the data sets within the business. So that was allowing me to kind of sharpen skills, understand how all of the different data points are connecting into single systems, Microsoft Stack systems, all of these other systems that are connecting through the use of GIS. We're able to kind of visualize geospatially, and how can we then improve that for our end users ultimately? What steps do we kind of need to take? So what I was doing here was looking at seeing how we can kind of improve the visual impact. As you may have seen in the previous slide, the ArcMap to the Arc Pro. It's not hugely different because we didn't want to detract away from users who are used to seeing this data set. We didn't want to misrepresent anything on a map that might mean that that particular area could be treated differently under the type of contract. So we kind of revamped everything. We moved away from the retiring ArcMap and moved everything over to sort of ArcGIS Pro, which obviously being a newer, improved platform, things looked slightly different and tools were kind of in different places, but ultimately it still served the same purpose. Not only that, I was able to kind of lean on what I had been doing previously and kind of redevelop how our applications kind of look and feel for our internal staff members. And not only that, we do have, alongside our enterprise, we've got our ArcGIS Online account that allows us to kind of tap into externally, public-facing people, and rather than just our staff members that might be held inside our internal environment, which is our portal environment. So we were looking at designing new applications, new data sets, more models to kind of help us really harness the power of our updates, as some of these updates, you know, they can be quite lengthy, and having that model to kind of take that manual intervention away from us allows us to be more creative and kind of see what is it that we can look to improve. Obviously, being in touch with ArcGIS field maps, understanding how that can kind of work both, you know, online and offline, it really was starting to kind of help me push my skills and look for more training. So bringing everything together, we have our interactive internal web applications. We have customized web applications for our individual sort of teams. You might have one for, like this one, for example, is solely focusing around our grounds maintenance. But we've also got a host of external data sets that we're able to curate to show where our area of interest is, where are all of our stock areas, and really kind of allow users to use these custom widgets as well that we've developed that are really allowing them to kind of self-serve and extract the data that they want when they need it. And that was really important for us, was to give our users, instead of coming to us to be able to provide the data, users that may not have never tried using GIS or experienced GIS now get the availability to kind of come into their internal directorate web application and really start using tools that we would use day to day that are really allowing them to kind of understand high level kind of analysis. So from there, we have also kind of started to explore the use of other suites of software within the Esri platform, so things like Survey 123 and the dashboards, and kind of moving up to upgrade our portal to kind of handle this. That has kind of taken that step now that has kind of allowed me to not only move from a GIS analyst, but move up as well to a more senior level analyst. And with that, all of the sort of roles around that are really allowing me to kind of move forward and explore what's available. So we're starting to kind of use the Survey 123 that is allowing our staff members to kind of go to any sort of grounds maintenance sites and physically report issues if they want to, with the use of photos that are telling us what these sort of issues are that they're finding on site, that we can then relay back to our relevant teams that are able to either respond back with the right information or address the situation that they might have found, using these interactive kind of pie charts as well. As you move in and move out of the dashboard, it will kind of show what are the most prevalent issues based on the sort of responses we're asking for. But not only that, we are kind of saying that we want to explore the use of more dashboards. So we have available dashboards for things like flood map and flood risk. Where do we want to identify those prevalent issues should there be an issue or a flood that's going to happen? Rather than being reactive, it allows us to start becoming proactive, in the sense that if we identify that there's a flood risk in a particular area, we can actually send messages out to our residents and just let them know that, look, we are here to support you, and if there's any assistance we can do we need to look at investing in sandbags for those particular areas. It really does allow us to kind of start pushing forward rather than being behind the curve and residents coming to us. So what does the future look like for us? Well, I suppose that's all going to kind of depend on what we want to do, but the main things that we kind of want to push forward with is we want to be able to be more self-serving, and we want to kind of look at developing more open portals so that residents and, you know, new people that may not want to call a contact center or speak to someone direct are able to kind of tap into this open platform that is allowing them to search what's around them. They may have just moved to a particular area and they might not know anything around that particular area. Having this portal that might have access to things like doctors' surgeries, banks, supermarkets, and all of these open source data points could allow them to just move to the area, log on to a tablet or a device and go, what's around me? Ah, there's the nearest doctor's surgery, or there's the school that I can get my children registered into. It really will allow them to kind of understand the geography around them, but they might also want to report issues that they're finding in their particular scheme. And we can then obviously tap into that. They'd be able to kind of use a reporting tool that would raise the issues. They get sent straight through to the right team at the right time, which allows us to be able to be more responsive and deal with these queries quicker. And not only that, we want to obviously bring a new look and feel to our internal website that has kind of been static at the moment, but using all of these other suites of softwares that we've got, we might want to start connecting into our Microsoft Stack system platform more, and that will just allow us to kind of really push the boundaries and accelerate our growth inside of the sort of Esri GIS and analytics sort of platform. So that has kind of touched on my sort of journey here. I hope it's given a little bit of insight, and I look forward to kind of doing more presentations like this where we can look at, you know, giving you these sort of demonstrations. But I'm going to pass you over to the next person, and that's going to be Adriana. Thank you very much.
Thank you, Jamie. So it's really interesting to hear how you've gone from no GIS experience to leading GIS at SNG, and how GIS at SNG has also mirrored that growth. As the organisation has grown massively over the last few years, it's great to see how GIS supports it. So now to pass on to Adriana, who's going to follow on from Jamie's where next, and look at how GIS can lead to better decisions and increased efficiency when exploring retrofit programmes to increase property sustainability. So over to you.
Thank you. Is my screen coming through okay?
Yes, it is.
Perfect. So thanks, Izzy. My name's Adriana Cosso, and I work in the technical team at Esri UK. And today I'm going to give you a technical demonstration. So we're going to go through 4 stages here. The first of which is we're going to go through a Learn ArcGIS tutorial, which will allow us to estimate solar power potential. And then we're going to compare our solar power potential outputs with EPC scores of our properties, essentially so we can make informed decisions on solar retrofitting. Then I'm going to create this into a shareable app that I can provide to my colleagues. And finally, we're going to bring this layer into Power BI so we can enhance the Power BI experience for your current users. So the tutorial that we'll be using today can be found on Learn ArcGIS. So Learn ArcGIS, if you've not heard of it before, it's got a wide variety of guided lessons and tutorials and series that are available to you, which are all based on real-world issues. There are nearly 500 tutorials, series, and notebooks to get started with. But today we'll be following along the tutorial titled Estimating Solar Power Potential, and we're going to examine the results of this in accordance with EPC scores to make informed decisions about retrofitting properties with solar panels. So when it comes to retrofitting your properties with solar panels, it's really important to look at it through a GIS lens. Understanding which properties have the highest solar potential will allow you to prioritize the ordering of retrofitting. And also, you'll save money on properties that aren't worthwhile investing in having solar panels, as they won't generate enough energy to justify the costs. So we can then begin to overlay this information with a property's EPC score. According to government guidelines, by 2030, properties have to be a C rating or above. So using GIS, we can then analyse which properties have the lowest EPC scores, but will derive the highest solar power potential. This will enable you to speed up your retrofit decisions and give you a tangible data output for you to make evidence-based decisions. Overall, targeting the interventions where it will make the most difference and bring the most value will save your organisation both time and money. So we're going to share the link to the Learn ArcGIS tutorial in the follow-up email that you will receive after this webinar, so you can follow along the steps yourself to derive your own solar power potential for your properties. The workflow that is shown in the tutorial can be replicated for any given area, so long as you have building footprints and a digital surface model. So just a quick note here. The requirements to complete the tutorial are that you need to either be a user, publisher, or admin role for your organization's ArcGIS online or enterprise account. And to conduct the workflow, you will need ArcGIS Pro and the Spatial Analyst extension. So as I mentioned earlier, we're going to be able to follow along the workflow as long as you have two layers, the first of which is a building's footprint layer. Now, to derive building's footprint, we can do this by using OS Master Map topography layer. This layer gives you access to the most detailed, current, and comprehensive map of Great Britain. And using OS Master Map's data for your housing association's land will enable you to derive asset data and visualize your residential buildings, garages, gardens, grass verges, and more. But the important layer that we're interested in today are those building footprints. This data is available to use through Esri UK. Now, to understand buildings in our ownership, we're going to be using a dataset called Title Info. Title Info allows you to view your housing association's land in addition to freehold land, leasehold land, commercial entities, adjacent housing associations land next to your properties, and much more. It's a premium data service that's available from Esri UK, and it provides access to information on title plans published by Land Registry. Title Info is available for England and Wales, and it combines different layers noted on the left-hand side of the screen. You can filter Title Info to only show land parcels that are owned by your housing association based on its proprietor name. So essentially, you can identify and map your entire land ownership area. If you take both of these datasets, Title Info and OS Master Map topography layer, and load them into ArcGIS Pro, you can then use the clip tool to cut down OS Master Map to the Title Info area so that we can only show buildings in your ownership. Then we can symbolize OS Master Map by the style descriptor field to show the breakdown of land classification and filter the layer to only show building fill. And that's how you can make a building's footprint layer for your housing association's properties using Title Info and Master Map. So Blue Sky's DSM LiDAR dataset offers between 25 centimeters to 2 meter resolution, and this is the second dataset that we're going to need to conduct the tutorial. If you're interested in acquiring this dataset or any other datasets that I've just shown, please chat to your Esri UK account manager or contact our sales team for more information. Now, we can overlay our building's footprint layer with the DSM provided from the Learn ArcGIS tutorial. To create the solar radiation layer, you'll use the Area Solar Radiation tool. Now, this tool is part of the ArcGIS Spatial Analyst extension, and it will take your DSM as the input. It calculates radiation based on a sophisticated model that takes into account the positioning of the sun throughout the year and different times of day, and obstacles that may block sunlight, such as nearby trees and buildings, and also the slope and orientation of the surface. The DSM provides the necessary information on obstacles, orientation, and slope. And the output layer will be a raster layer where each cell value is the amount of solar radiation in watt-hours per square meter at that location. So once we've got this dataset ready, the next step is to convert the units of measurement from watt-hours per meter squared to kilowatt per hours per meter squared. And then we're going to symbolize this data. So we've got uniform symbology of all of the solar radiation raster layers to make sure we can visually compare them. Now that we've identified solar radiation for our area of interest, we're going to need to identify then which rooftops are suitable for solar panels. And to do that, we're going to crop our dataset to only show rooftops that meet the following criteria. First of all, we're going to show only rooftops that have a slope of 45 degrees or less. And this is because steep slopes tend to receive less sunlight. So next up, our roof surfaces should receive at least 800 kilowatt hours per meter squared in solar radiation if solar panels to be installed. So again, we're just cropping the dataset to meet this criteria. And finally, our rooftops should not be north-facing, as we're in the northern hemisphere, and north-facing rooftops tend to receive less sunlight. So many of the north-facing rooftops were actually removed when we removed the areas of low radiation, but some did remain, and that's why we're just going to run this step. So now that we've identified the most suitable cells for solar potential, we now need to understand that at the building level. So in this step, we're going to calculate the area of each building that is covered by its suitable cells in meters squared. And then we're going to generate the average solar radiation for each building in kilowatt hours per meter squared. And you can see this in the mean field in the tab on the screen that shows our data. So now that we've identified solar power per building, we need to understand whether the buildings are actually suitable for solar panel installation. And we're going to apply some further criteria to determine this. If a building has less than 30 meters squared of suitable roof surface, it's generally not suitable for solar panel installation as it's not worth the investment. So we're going to remove all of the buildings that have less than 30 meters of suitable roof surface. Next, we're going to convert the usable solar radiation values to electric power production potential. The amount of power that solar panels can produce depends not only on solar radiation, but also the solar panel's efficiency and the installation performance ratio. Here it's just important to note that the calculation on the screen uses approximations, and that all figures generated should be used for guidance only. Now that we've calculated which buildings can generate the most power from solar panel installation, it's time to symbolize our findings so we can find it easier to understand. So what we can see here is that those red buildings are able to derive the most power, whilst yellow will derive the least. We do tend to see a pattern here where the larger buildings have higher electrical power production potential than single unit dwellings. Now, this would be because larger buildings do have larger roof surfaces, but they also do have a higher electrical power need. So this is just something to note, having found our findings from running this tool. Now, behind the scenes, I've converted my EPC scores to numerical values so that A equals 1, B equals 2, and so on. Now we can multiply our numerical EPC values by the estimated solar power potential that we've just calculated to gain an understanding of which buildings have the lowest EPC scores but will be able to generate the highest solar power potential if we installed solar panels on the building roof. Again, we're applying the same symbology in the last step so we can understand the layer better. So the buildings in red have low EPC but high solar power potential. So we've now uploaded the output layer from ArcGIS Pro into ArcGIS Online, so we can create an easy to use interactive application that can be shared with my organization staff. And to do this, I'll be creating an instant app. The idea of an instant app is you go from map to app in just 5 minutes. So I'm going to be using the interactive legend template today, because within this template, I'm able to compare the relationship between two layers. So essentially, my users will be able to explore the relationship between low EPC scored buildings and buildings that will derive a high solar power potential. Or if they'd like, they can just view these two layers individually. I can preview how the app will look before I'm committing to making it. When I'm happy with the template selection, I'll just give the app a name and its details, and then I will press Create Application. Now let's take a look at how a finished product could look. So I've added a splash screen here to notify users of the app's purpose and how they can interact with it before they go into the app. Now they're able to interact with the widget, the relationship widget that we'd added, so they can filter the map to explore the relationship between the two layers. And I've also then configured pop-ups, so when someone clicks on a building, they can get a custom summary that outlines the information from the estimated solar power production for that location and the potential costings of solar panels based on average costings in the area. And that's how you can share an interactive application with your colleagues so they can easily explore the data and make informed retrofit decisions. Now, there may be some users in your organization who view and consume data in Power BI. So the ArcGIS for Power BI integration allows you to easily create maps that can elevate your Power BI dashboards and give you a spatial understanding of the data in a way that you might not have seen it before. So whilst in Pro, I used the Calculate Geometry Attributes tool to generate X and Y coordinates for each of my buildings that we had analysed, because this is a location format that is easily consumable in Power BI. So you just saw me drag those X and Y coordinates into the tables. And then I've color-coded the map based on the potential to derive solar powers for the buildings. Now, if you want to interact with the map, you can simply select on a location to view the item's attributes. You're also able to select multiple points at once if you'd like to figure out information for a specific area, for example. And as you can see, a pop-up appears on the screen and you can go and interact with the information that we've input. If there's a certain address that you want to view the information for, you can simply use the search bar and type in that address. You can symbolize your data based on color fields, so you're able to enable clustering as well to understand large data sets at a high level, and you can update the color and size of your clustering accordingly. And then in terms of symbology, we can also create your data in a heat map to understand where hotspots of the data are. So in this case, it's where there are lots of houses with high solar potential and low EPC scores. And then just generally, you can also change the symbology of points on a map. So they could be crosses and squares rather than circles, for example. If you're logged into your ArcGIS Online account, you will also have access to your organization's base maps, and this will allow you to view your data with more context. You can then enrich your data by adding reference layers. So you can bring in information from your ArcGIS Online accounts or other members of your colleagues from their organization accounts as well. Or you could also bring information in from the ArcGIS Living Atlas. Now, for those who might not know, the Living Atlas provides ready-to-use curated content from authoritative data sets. So you could, for example, bring in census data. You could also further then enrich your map by adding infographic variables for your country. So for example, now I've just gone ahead and added average household size to my map to help gain additional information when making informed retrofit decisions about the properties. So as with the other widgets within your Power BI dashboard, your map will update the other widgets accordingly, like your graphs and your counters, and also vice versa. So if you were to click on these widgets from outside of the map will then filter to just show those properties. So here we're seeing just those with C rating EPCs or F rating. Overall, the ArcGIS for Power BI integration allows you to visualize your data through a spatial lens within your existing BI system, and then interact with the data to add additional context to your dashboards. And that brings us to the end of the technical demonstration. So we've followed the Learn ArcGIS tutorial and then created a shareable application for our colleagues, and we've also brought this data into Power BI. So thanks for listening, and I'll now pass over to Izzy to wrap up the webinar.
Thank you, Adriana. So that brings us to the end of the webinar today, and I'm sure you'll join me in thanking all of our guest speakers. It's been great hearing how different organisations use GIS and the range of different use cases shown here. As a reminder, do put any questions you have onto our Slido. While we don't have time to pick these up now, we'll be following up with the questions and answers along with the recording after the webinar. If you do want some more information, this can be found on our website, the address of which is on screen. We're also releasing the second part of our housing tutorial series, focusing on mapping our green spaces and trees. So this can be found through the QR code on screen, but will also be linked in the follow-up email. Our annual conference is also coming up on the 14th of May, and it's free to attend, but you do need to register for your place. It's the largest GIS conference in the UK, and we do have a dedicated social housing pathway with highlighted talks and a lunch meeting for networking. So that's just for me to say thank you for listening. I hope you have a lovely rest of your day, and thank you.